Introduction to solid state device theory. This chapter will cover the physics behind the operation of semiconductor devices and show how these principles are applied in several different types of semiconductor devices. Subsequent chapter will deal primarily with the practical aspects of these devices in the circuits and omit the theory as much as possible. Semiconductors are materials that exhibit electrical behavior somewhere between that of insulators and that of conductors. Conductors present very low resistance to the flow of current, whereas insulators conduct very little current even when a large potential difference is applied. A semiconductor exhibits intermediate conductivity because it has more available charge carriers than an insulator but fewer than a conductor. Example of semiconductors are silicon and magnesium, germanium. Why are semiconductors so important? Well, with the right amount of impurities and clever arrangement of materials, semiconductors can be used in the fabrication of resistors, capacitors, inductors, and most importantly, transistors. It is because of semiconductors that we have incredibly complex technologies such as computers and cell phones. These devices are based on integrated circuits which can combine millions or even billions of transistors into one small package. In itself, control of electric charge flow is nothing new to students of electric circuits, which is control the flow of electric charge as do potentiometers, especially when connected as variable resistance. Neither the switch or nor the potentiometer should be new to your experience by this potential point in your study. The threshold marking the transition from electric to electronic then is defined by how to flow of electric charges in control rather than the whether or not any form of control exists in circuit. Switches and rehosers control the flow of electric charge according to the positioning of mechanical device which is actuated by some physical force external to that circuit. In electronics, however, we are dealing with special devices about able to control flow of electric charge according to another flow of electric charge or by the application of static voltage. In other words, in electronic circuit, electricity is able to control electricity. History pursuant to the modern electronics era was invented by Thomas Edison in 1880. While developing the electric incandescent lamp, Edison found that a small current passed from the heated lamp filament to metal plate mounted inside the vacuum envelope. Edison found that a small current passed from the figure below. Today, this is known as the Edison effect. Note that the battery is only necessary to heat the filament. Electron would still flow if a non-electrical heat source was found. Edison effect filament evolve or vacuum additive deformation tried vacuum tube amplifier. Macaroni Wireless Company advisor John Fleming found that external applied current plate battery only passed only direction from filament. Historically, the era of electronics began with the invention of the Ardian tube, a device controlling the flow of an electronic stream through a vacuum by the application of small voltage between two metal structures within the tube. A more detailed summary of so-called electron tube vacuum tube technology is available in the last chapter of this volume for those who are interested. Electronics technology experienced a revolution in 1948 with the invention of transistor. This tiny device achieved approximately the same effect as the Ardian tube, but in a vastly smaller amount of space with less material. Transistor control the flow of electron charge through the solid semiconductor substance rather than the through a vacuum, and so transistor technology is often referred to as solid state electronics.